Hello, everyone. Happy Friday, or should I say Friday? Woohoo! I'm Sonia, and I love science. I'm not particularly savvy in the lab or some mathematical genius. I just look around me and I wonder about things, and I let my curiosity lead me down a learning pathway. So, on behalf of CK-12, got my shirt, let's do some science, ask some fun questions, and travel down a learning pathway together. Alone, but together. I have a really special story that I'd like to share with you today. It is about a very extraordinary scientist, Sir Isaac Newton. And it just so happens that many of his most important discoveries were made while he was social distancing or in quarantine 355 years ago due to the bubonic plague. He was a college student and had to go home from school, just like many of you. And during this time at home, he did some math that led to his creation of what we now call calculus. And he observed sunlight entering a prism and splitting up into all the colors of the rainbow that led to our understanding of optics. And he observed an apple falling from a tree. Have you ever heard about this? Well, seeing the apple fall made him wonder, what if the force that caused the apple to fall to the ground was the same force that caused the moon to orbit the Earth, which led to his development of the universal law of gravity? So I hope that this story really inspires you. No pressure. You don't have to go invent calculus or anything, but I hope it motivates you just to wonder and to create during this time and after. Many people before Newton observed the fact that objects always fall to the ground, right? That was nothing new. However, Newton's breakthrough was that he proved the law of gravity applies to everything in the entire universe that has mass. That's why we call his law of gravity universal. And it's really why this law is so important and beautiful. It was the first scientific law to apply to all massive objects in the entire universe in the exact same way. From an apple to the moon, it unified all things. So the scientific principles that apply here on Earth are the same principles that apply to any object you can think of in outer space, small or large, near or far. All were unified by gravity. Pretty cool, huh? So one question that might come up at this point, what gives an object its mass? That's a great question. Definitely investigate that one. Another learning pathway you could go down is to figure out the difference between mass and weight. There is a difference. Let's say you got to walk on the moon. I would be so proud of you. Your mass would not change, but your weight would. Why? Hop on CK-12 after this live stream. There's a lot of good content on those topics, mass and the difference between mass and weight. So now that we've got the first big idea regarding gravity down, that gravity applies to everything in the universe that has mass in the exact same way, let's explore it further. Newton thought of gravity as a force of attraction between things that have mass. So anything that has mass, large or small, exerts gravity on other objects with mass, pulling it towards its center. Gravity can act between objects that are not even touching. In fact, gravity can act over very long distances. Why does an apple fall from a tree? Gravity. Why do skydivers fall from a plane? Gravity. Why does the moon orbit the Earth? Let me hear you. Gravity. Why does the Earth orbit the sun? Shout it. Gravity. Why aren't you flying through the roof right now? Gravity. The Earth is pulling down on you towards its center, but you are pulling up on the Earth. Both you and the Earth are made of mass and exert a force of attraction on each other, equal in magnitude, but opposite in direction. So as the apple falls from the tree and you're there to observe it, why doesn't the apple fall towards you if you're exerting a force of gravity on it, right? The Earth is so much more massive than you that its gravitational pull on the apple is immensely greater. According to Newton's universal law of gravity, the strength of gravity between two objects depends on their mass and their distance apart. That's a really big idea, okay? So it's dependent on the amount of mass and their distance. Newton's law is amazing, but it doesn't explain why gravity occurs. It only describes how gravity seems to affect objects. Albert Einstein came up with a theory of gravity that actually explained gravity rather than simply describing its effects. Einstein showed mathematically that gravity is a result of the warping of space-time. Einstein's new concept of gravity stated that mass causes the space around the mass to curve and also distorts time. We call this his general theory of relativity. How cool is that? Well, okay, it gets even cooler. Einstein first hypothesized the existence of gravitational waves in 1916. These waves were thought to be waves in the fabric of space-time and would provide evidence of his general theory of relativity. Almost exactly 100 years to the date, on February 11th, 2016, researchers from the LIGO Observatory announced the first detection of a gravity wave. Do you guys remember that a few years ago? The signal was a short 1/4 of a second blip of sound. It actually kind of sounded like that. It was an auditory representation of the ripple felt by 2 LIGO observatories on either side of the United States. It was caused, get ready for this, by the merging of 2 black holes 1.3 billion light years away. So I'm going to do something a little different today. Rather than walk you through the simulation step by step, I'm going to quickly show you 2 of them and let you play around. Because just like Newton and Einstein, having time to wonder about things and explore on your own is key to discovery. Okay, so let me share my screen here and hop on the CK-12 website. Here we go. There's no place like home, no place like home. All right, there's home. Okay, so the first sim, and all the links are going to be below this video for easy access, but just in case, CK-12 homepage, in the search bar, let's put Newton's apple, because that was the first thing that we discussed. And we have this beautiful sim called Newton's apple, so click right there. And here you see the big question. What did Isaac Newton see in the falling apple? And it takes you through a great introductory video that kind of explains what I shared with you, the story of him observing the motion of the moon and the motion of the falling apple. And in this sandbox, you have the ability to adjust the distance between the Earth and the moon and the distance between the Earth and an apple. So I encourage you to hop on this simulation. Why don't you try to adjust the distance of the apple, maybe double it, and see what happens to the force on the apple. Then double the distance between the Earth and the moon and see if the same things happen to the force of gravity. That idea that Newton's law is universal, meaning it affects all objects in the universe in the same way, should be demonstrated by your calculations here, okay? So now going back, I'm gonna just hit back. We'll go back to the CK-12 homepage just because it's easy. And I'm going to type in black hole. All right. This is my most favorite simulation. I really hope you have fun with this one. Okay. Look how beautiful this is. Does a black hole bend time? Okay, get ready. It gets really good. Let me make it bigger here so you can see it. What would happen if you fell into a black hole? Think about that one. What would a friend outside the black hole see as you fell in? At least you could bring a friend, right? Could you still communicate with your friend by radio? Would you appear to age more slowly or more quickly? All right, so all this can be investigated in this sim. It's so cool. Okay, so you can adjust the position of a clock and you can get it towards the event horizon or far away from it. And you can measure its effect on time. You can make the black hole small or large. And you can also put a space probe and see how the frequency of the radio waves emitted change. So hop on this sim. As always, the simulation ends with 4 more real world questions that carve out learning pathways for you to travel down. They're just so beautiful. Here's one. How is a black hole formed? So I hope that you hop onto CK-12, explore these sims, have a wonderful weekend, and I look forward to, I'll come back on the screen. And I look forward to seeing you on Monday. We're going to explore the magnetic field around the Earth and talk about if our force field's real. Okay, it's going to be fun. See you then.